Good day, ladies and gentlemen. Let me introduce you the main features of the software DREAM, that stands for Diagnostic Rolling Element Analysis Module. The system is used for automatic condition diagnostics, and it has the three main features. The first feature is automatic setup of the vibration measurements by mechanical data of your machine. The second thing is automatic diagnostics, finding what are the defects in the machine. And the third one is long-term condition forecast. So it will tell you how long the machine will stand in this condition with these defects until you need to make the next measurement, or will give you recommendations on the repair and maintenance. So if we consider our database, everything starts from the setup, and everything starts from the setup of the diagnostics and vibration measurements. So we can select some of our machine, for example this one, and here we have setup of the motor, and we have some fan here as well, and we can set up the bearing here for the diagnostics. So first what we do is that we say that in our suction motor we have some additional equipment. For example, it can be an asset or a bearing. We say that this is my bearing and say that it has some type. This is the type of the diagnosable types of the machines that we can make diagnostics of. It's a great list of the machines, but here we have just a bearing, just a rolling bearing, and we say OK. Now we need to select the model of the bearing. This is bearing designation, so that we know what are the sizes of the bearings, and we select the bearing from the database. We can import the bearing designations from all the manufacturers, and here are, for each bearing, we know their sizes and number of balls, etc. So we select it, and that's it. We have my bearing that we can put here and say that this is this one. Now we go to this bearing and we need to set up the measurements. If we go to the configuration mode, we see that we have no measurement locations, we have no measurement setup, but we can do it automatically. How we do it? We go to the diagnostics mode and we say that we are going to make diagnostics of this bearing and add a new diagnostics. The new diagnostics for the rolling bearing, and this is a rolling bearing, can be bearing and gearbox, bearing and shaft light, belt transmission, etc., etc. So we say that this is bearing and shaft line. And we make diagnostics, and what it asks for is the rotation speed. So consider we have a 3000 RPM motor, and it is induction motor, so it may have the rotation speed from 48 up to say 50 Hz. If we have two bearings in one bearing shield, we can enter the paired bearing, but we do not have it here. And this is the list of the defects that we can find in the bearing. Here is some installation defects like shaft wobbling, non-uniform radial tension, misalignment of outer race. Then we have a list of wear defects. This is wear and cavities on all the races. And then we have some lubrication defect, defect of support structure, rotor unbalance, etc., etc. The levels for defects are automatically defined for envelope spectrum in percentage of modulation and for auto spectrums in dB. And we can create a measurement point where we will measure this bearing. The measurement point name for default is the same, and we say that we will measure vibration, absolute, on the casing. OK. OK. We select this measurement point. OK. And say finish. This procedure creates automatic setup. Now, if we go to back to the configuration, we see that we have set up envelope spectrum and auto spectrum with very many setup. with very many different kinds of setup. The envelope filter, we know the maximum frequency, etc., etc. So this is automatic setup. We entered only the bearing designation and rotation speed, and we have set up our data automatically. Now we go here and say that we want to measure it. This brings us create route system, and we create a route for this measurement point and bring all the measurement points with all the measurement setup to the data collector. We load it to the data collector, and after measurements we can see the measurement results. For this we go to the analysis. In this measurement point we don't have any results, but let's go to the other measurement point. For example, we go to our demo machine that we can measure right now. It looks like a stand with a motor and couple of bearings here. So we will make diagnostics of the bearings, and we will make diagnostics of the motor itself, the induction motor. So here we select a bearing, number 2, for example this one, and we go to the analysis and look at the measurements. We have done envelope spectrum measurements, and we have done auto spectra measurements. So this is quite a complicated spectra with some lines, and what to do with it. We have a choice to make automatic diagnostics. What is automatic diagnostics? You select the measurement results, because we may have very many measurement results in the database, but we select the last one and say diagnose with details. It asks for the actual rotation speed that we can measure with the tachoprobe, or we can enter it manually and say OK. Now the automatic diagnostics is coming on. So what we see here that we have some recommendations. The recommendation is to measure it on certain date. So the measurement date initially was on the 10th of August, and now it asks it was on the 8th of October, and now it says measure it again on the 28th of October. What we have found? We have found a couple of incipient defects. This is wear of inner race, incipient, and these are the symptoms for this very defect. So this is inner race and some rotation speed. We have some shaft coupling. This is just because of some rotation speed in the envelope spectrum and some rotation speed harmonics in the auto spectrum. But generally this is good, and this is green, and you don't have to do anything with this bearing except for measure it next time at the date that was stated here. If we take another bearing on the same machine, bearing 1, we also have a number of measurements. The measurement is a little bit different. Actually, we can even compare it. So, for example, we take this measurement result and say copy. Then we go to another envelope spectrum of a different bearing and say paste. OK. And we can display both of them, so you see that there is some difference. But we go to our bearing number 1, to the envelope spectrum, select the result and say automatic diagnostics. Again, enter the rotation speed or measure it, and we get the results. And now it says replace the bearing. The previous bearing was good, this bearing is bad. Why? Because we have cavities on outer race, we have cavities on rolling elements. One defect is severe, one defect is medium. Additionally, we have a problem with shaft alignment, and it says shaft wobbling, severe. So we have to verify the shaft alignment to check it, but first replace the bearing. Let us see what is the symptoms for the defects. So we have cavity spellings on rolling elements because these lines are present. This is the rolling element rotation speed, ball spin frequency. This is the fifth harmonic of ball spin frequency plus some harmonics of ball spin frequency modulated by the cage, or FTF, fundamental train frequency. So we have the full list of symptoms, and they are shown in the spectra. So these are the different frequencies, and this is automatic diagnostics, and this is automatic condition forecast. So this bearing has no safe operation forecast, so you have to replace it. The other bearing, this one, has quite a long condition forecast, so this is in a good condition. If you go to the diagnostics, we will have the full report. So this is, for example, recommendations, next measurement date. So this is a good condition of the bearing. It has some minor defect. This is the lines of them with the diagnostic symptoms. So this is wear of inner race. This is shaft wobbling. So all the symptoms are here. If we take a different bearing, we have the recommendations like check alignment and replace the bearing. So first, of course, replace the bearing, then check the alignment of your machine. And this is again all the symptoms are presented in the report and the spectra, so that you can do the analysis. Of course, this system also have quite many possibilities of the manual analysis as well. So, for example, if we consider this spectrum, first of all, what we do in this spectrum, we will find the frequencies. Rotation speed of the shaft is here. Yes, we have quite rotation speeds, and we can have a cursor. One. Okay. So this is the first harmonic of rotation speed, the second, the third, etc., etc. We can have the rotation speed of the cage. Yes, it is here, quite a small one, but still. This is ball spin frequency. Actually, nothing is here, but if we look at many harmonics, maybe we find something. We have BPFO. This is outer race. Actually, this is quite an exact fit. And we can have a cursor with this very frequency, like outer race. Okay. Maybe we need slightly change it, like this. And this is we see that this is an exact fit. Additionally, we can see the sidebands. Sidebands on rotation speed of the shaft, for example. Yes, something is here. This is the rotation speed of the shaft. This is rotation speed of the this is the sidebands with the rotation speed of the cage. We just need to rotation speed of the cage, and we see that yes, this is rotation speed. This is the BPFO modulated by FTF. We can change the position of the cursor. We can change the position of the sidebands, and maybe we will find some other modulation like this. Yeah, this is quite a modulation. We see the modulation frequency, the main harmonic amplitude, and the main harmonic frequency. So this is all the list of the bearing frequencies that we have here. So this is the manual diagnostics. Now we can look also on the diagnostics not only of the bearings, but we can look also on the diagnostics, for example, of electrical motors. So in our demo stand we have an electrical motor. For the electrical motor we need to make certain amount of measurements. So if we consider it and look at the configuration, we see that we have 4 measurements. These are the measurements in 2 different measurement points in 2 directions. The measurements locations are like this. So this is vertical measurement, or radial, we call it radial measurements, and this is tangential measurement in the tangential direction. Once we do all these measurements, we can go to the analysis for this motor. For example, here we have a high frequency resolution spectrum, and this is the rotation speed. If we look at the rotation speed, we will see that it splits into many lines. If we look at the second harmonic of the rotation speed, we also see that it splits into many lines. This is a symptom of the squirrel cage defect. But this is where experts, we know this. If we are not experts, we take this measurement and make automatic diagnostics. Okay. It says squirrel cage or rotor winding defects. Additionally, it has some more symptoms, but these are the main symptoms are from this spectrum. This is split of this line, and it does it automatically. If we consider a different motor, for example, we have the motor on the previous machine, and we will make diagnostics of this motor. We look at the spectra. We can look at the same spectrum that we have seen. You see that this line is not split into many, it's just a single line. We have some additional spectra into 2 different points, and if we select it and make automatic diagnostics, it will tell us dynamic eccentricity of ear gap. Dynamic eccentricity of ear gap, it means that the rotor is not in the bended, and the minimum, it has different ear gaps from different sides of the rotor, and the minimum ear gaps rotates with the rotation speed. So these are the symptoms in this very spectrum for the dynamic eccentricity of ear gap. Actually, this is the slot pass frequency modulated by the rotation speed. So this is automatic diagnostics, and you have to correct this problem. If we consider a different motor, like here we have a pump like this. This is a huge pump for pumping oil on the oil pipeline, and we consider this motor, look at the spectra, and again we just make the automatic diagnostics. Okay. It says static eccentricity of ear gap. This is not dynamic, but this is static eccentricity of ear gap. Plus we have distortions of main supply. This is quite possible. But the main problem is static eccentricity of ear gap. And you have, this is the reason for this static eccentricity in this very motor. It was the problem with the soft foot. The motor was not properly aligned, and the case of the motor was squeezed. So you have to realign your motor, and in this way the static eccentricity of ear gap will disappear. The other possible reason for it is wear of the bearings and just the rotor moved in the starter. So this is the automatic diagnostics. Thank you very much for listening. Hope you enjoy.